Sorry, guys. We just remember. Sorry. Okay. So to use a double derivative test for min and max, the first derivative has to exist, okay, at those locations. So I'm going to find the critical points. Because it's so nice, it gave us in factor form. Can we find two critical points from our f prime? What are the locations? 2 and 1, okay? Now, to use double derivative tests for min and max, all we have to do is plug it in. So, let's plug it in those locations. F prime prime at 2, all we need to know is positive or negative, and that's it. And so it's F prime prime at 1. So at 2, positive or negative? Positive, Tony says. Are you sure? What? It's 0. Okay, how about F prime prime at 1? Positive and negative?
Positive.
Well, 1 times 3 is 3 minus 1. That's negative, right? Negative times a negative is a positive.
Isn't that the prime prime?
Yes, we are doing prime prime.
Oh.
Prime prime, So we just said positive. Would you guys agree? Now, if we are using second derivative, what was the rule for L max? Double derivative has to be less than 0 at that location. And then this one has to be greater than 0. So based on our definition of prime prime for max and min, do we have a max? No. Do we have a min? Yeah, at where? X equals 1. Then what the heck is x equals 2? What is that?
It's a hole.
It's not a hole. It's already used as what? An IP. It's already used as an inflection point. Right? Remember, the derivative for the rule for second derivative is it's an L max only if the value is negative. Double derivative has to be positive for L min. If it's 0, I can't use it. In this case, as you can see, it's already used as an inflection point. Okay. Any questions there? Okay. Move on to 8. Last example. Woo! For 3. For the next couple of days, actually. I'm not lecturing for the next few days. We've been lecturing like every day for like a week straight.
For like a year straight.
I know, that's how it feels. All right, example 8. Sketch a smooth curve, okay, of y equals to f of x through the origin with the following properties. Property number 1, okay, double derivative has to be negative for x is what? Right, by the way, what is that describing? Concavity? Is that concave down or concave up? Concave down, because double derivative is negative. On the other side, it's also describing what? Concavity. Concave up or down? Up. Now, how is that different than max and min? It is second derivative.
It's the shape of it.
It's the shape of it. If I say this, f prime prime is bigger than 0 for let's just, I'm making this up, okay? This is not prime. For x equals 5. What is that saying? How is that different from what it's typed in the question itself? But what is this one describing? What's my made-up value describing? It is a local min, right? Because look, the double derivative is bigger than 0, and it's giving you one location of x. Okay, so this is really describing L min. But that's not in our problem, right? I'm just making that. Okay, let's sketch it out. Here we go, y'all. This function is smooth and continuous. What does it have to run through? The origin. So let's plot our dots. Everything on the left side of that dot has to have what concavity? Down. So, is that down? And then everything on the right means up. Is that up?
Yes.
So is that okay? Yes. That's it. Okay. B, our last thing, and then we'll summarize it up. And I gave you the whole page for summarizing because that's how long it's been. Okay. I know, right, Marco? Sketch a continuous curve. It's supposed to be y equals f of x. Y equals f of x with the following properties and label the coordinates where possible. Except I never gave you any properties. So we have to write this in ourselves. I forgot to type it. So now you should appreciate all the typing that I've done for you. It should be a 3 by 1, 2, 3, 4, 5, 6, 7, 8. 3 by 8. There you go. 3 by 1, 2, 3. Oh, you don't need that column right there. 4, 5, 6, 7, and 8. Okay, so make those 3 by 8. So this is x, y, and curve. I'll slow down because now you actually have to write it out like your parents used to when they were in school.
I don't do this.
Carved it on the rock.
Okay, so x, y, and curve. Right, let's write down the description before we even start graphing. Over here, when x is less than 0, y value doesn't have anything, and description of the curve sets falling, comma, concave up. Okay, so that's your description. Then next one, at 0, your y value is 2, and description of the curve is horizontal tangent. Then in between 0 and 3, non-inclusive, the description is rising, concave up. At 3, you have an output of 5, and at this location, I would like for you to have an inflection point. In between 3 and 5, non-inclusive, I would like for you to show me on your graph as a rising piece and concave down. At 5, you should have an output of 8, and I would like for you to show me that it is a horizontal tangent at this location. And your last information, everything bigger than 5, I would like for you to show me that the curve is falling and concaving down. Okay, so those are just the description, and now you have to graph it out for me. All right, so what's the smallest x value that we have so I can draw my coordinate plane correctly? 0. The largest y is 8, so I need 8 tick marks on the top. 5 tick marks to the right. Everything else is not as important, right? Okie dokie, here we go. 1, 2, 3, 4, 5. 5 on the right, 8 on the top. 1, 2, 3, 4, 5, 6, 7, 8. All right, we are graphing out f of x, y'all. If this is on your exam, which, as you know, there's lots and lots of sketches over the years, what would you do? How would you start? Yeah, let's plot the points. Why not? Let's plot all those dots. 0, I go up what? 2. Yep. 3, 5 sounds like a good idea. 3, 1, 2, 3, 4, 5. Yep. Next.
5, 8.
5, 8. You are correct. All right. So now I have those dots, those anchors. Everything on the left side of 0, based on your curve description, you need to have to show what? Falling means what, y'all?
Concave up.
Falling. What is that saying? What is it describing? The slope is negative. Slope is negative. Okay. Concavity, it says on this side, everything to the left-hand side of 0, you need to show me that it's concaving up. So how would you draw it so that's going to, that's right, like half a U, right? Yeah. Any size you want, as long as it looks like it's half of a U. In between 0 and 3, it says rising. Rising is describing positive slope and concaving up. So the other half of the U, would you guys agree? Remember, this is smooth and what? Continuous. So make sure it looks like smooth and no holes or gaps, anything. So now, at this location, 3, 5, it should be what? Inflection point. Now, if we go from 3 to 5, I should have what kind of curve? Positive slope and concaving down. So how would you show me so that's concaving down? Yeah, the other half of the cubic. Would you guys agree? Yep. What? And then at 5, 8, I should have a what? Horizontal tangent. So that means the slope is 0. But everything to the right of 5, I should have falling. So like that. That's not too bad, is it? No. Okie dokie. Last page. I saved the entire page just for summary. Oh, yeah. All right. This is it. After this, we'll do an egg roll. I know, right? Ready? Summary. All we want to do is eat. We should have an egg roll days, right?
We always say that.
I know.
It never happens.
Somebody's got to wake up early enough to go to a Vietnamese store that's open that early to pick up egg
We
rolls.
eat the egg rolls.
Same.
When you launch your merge, we'll have an egg roll party.
Somebody has to design my merch. I just learned that word merch when Trey said it. I was like, what are you talking about?
See, you teach us things, we teach you things.
Oh, yeah. I'm like, and then another student said something like, what are you talking? Like, what is that word? Okay, sorry, summary. I'm always on a tangent.
That's a good question.
Number 1. Differentiable. So, differentiable function. Let's say y equals f of x. Means, and I used this word yesterday on your homework quiz. Graph me a differentiable function. What do you think it means? It has to be smooth, and it has to be continuous, and it has to have a slope every single place, right? Point. So can you have holes in there? No, there's no discontinuity in differentiable, so make sure you're very careful. Differentiable function, let's call it y equals f of x, means f of x is smooth and continuous. It's already said differentiable. Continuous and may or may not have increase or decrease. And may or may not have increase or decrease. What do I mean by may or may not have increase or decrease? Give me an example of a function that does not have increase or decrease. Right. That's smooth. That's continuous. It's differentiable. It's 0. But it's not an increase or decrease. Okay? Now let's go to y prime is bigger than 0. When the slope is positive, okay, we always talk about it increasing. So increase, and we use from left to right. From left to right. Okay. And maybe wavy. Maybe wavy. y prime is less than 0, then we are talking about decrease. And again, increase and decrease, we always talk about from left to right. And maybe wavy. Now, double derivative. Double derivative. When it's bigger than 0, we're talking about what? Only min if it's a location, right? But most of the time, if we're talking about concavity, concave up when it's bigger than 0. Now, for this one, I'm spelling out no waves. So don't go surfing. Okay? F of x may rise or fall. Okay. The rise or falls really describes what?
Slope.
The slope, first derivative, okay? And then the phi double derivative is less than 0. Similarly, it's going to concave what? Down. No waves, okay? Hi, Lucian. Okay. F of x may rise or falls again. Okay. Don't worry, we recorded halfway for you.
Okay, thank you.
6, we are talking about inflection point. So inflection point is when y prime prime, the sign of it changes. Would you guys agree? The sign changes. So it's either positive to negative or negative to positive. And I want to add this on, and the tangent exists. By the way, if I use the word tangent, what are you thinking about? Yeah, the slope, right? Okay, tangent and tangent line, would you agree that's kind of talking about the same thing? Okay. Number 7. Is French? No, that's Espanol.
No.
Oh. What's fetch?
Set.
Set.
How do you say 7 in Vietnamese?
Bite.
Bite?
There you go. Y prime, okay, changes. You just learned 3 different languages. 4. All right. Y prime changes sign. That means f of x has an L min or an L max. Okay. So if the first derivative changes from positive to negative, you either have a max or min. Y prime equals to 0 and double derivative is less than 0 at C. What are we talking about here? Min, right? Min or max?
Nodding because I was right.
Min or max? If it's less than, we're talking about min and max now when it's talking about double derivative. If the double derivative is negative and the derivative exists at a particular location, not an interval now, a particular location, we're talking about a max, okay? Then f of x is L max at C. And 9 is the same thing except it's L min. Y prime exists, okay, and it equals to 0. And y prime prime is greater than at C. That means f of x is L min at C. Whew. That is an egg roll, y'all.